All right. Thanks everyone for joining another 15-minute Feature Friday. Today we're going to talk about smart codecs. And for those who've been around for 2 years or more, this may be a little deja vu. I covered the same topic back in January of 2017, but we've obviously added a lot of people to the company since then, and figured it might be time to just go back and do a little refresher on it. So we're going to talk about what a smart codec is, how do they work, who offers them as far as which camera manufacturers offer them, what are the pros and cons, and do a little shout out to e-learning, and then we'll kind of jump in and show a little demo of some of the benefits firsthand. So what is a smart codec? It's essentially a more efficient way to do H.264, H.265 that can lower the bandwidth and the storage by up to 50% and sometimes even more. So it's something that's been around for probably maybe 2.5 years or so, 3 years, something like that. I think Axis was the first one that came out with it, but it's been around for a while. And how do they work? It kind of varies from camera manufacturer to camera manufacturer, but a smart codec will take advantage of any of the following here. So one is that an area of the scene that's irrelevant, meaning there's not activity going on or something like that, more compression gets applied to that area of the scene. So it'll look lower quality in that area, but because there's no activity or anything like that, like take a white wall or a bunch of cars sitting in a parking lot or something like that aren't moving. If there's no activity around it, it's not really a need usually to have a higher quality image there until it actually becomes activity around it. So it'll put more compression on the video to drop that down. The GOP size, which to explain GOP stands for group of pictures. And the way it works with H.264 and H.265 and even MPEG-4 is that every GOP starts with an iframe or a keyframe, which is essentially a frame that where, if you think of it, all the pixels are populated. So it's a full frame. And then every subsequent frame in the GOP is just what pixels have changed for that frame, and they always reference back to the main keyframe. So they reference back to that so they can create a full image, but each subsequent frame is just essentially what has changed. So by default in our software, we have a GOP that is 1 second. So every second, say you're doing 15 frames per second, you have your keyframe, and then you'd have 14 of these change frames. So what the dynamic GOP does is it can dynamically scale that out to a longer GOP size, which means that your bandwidth lowers because those change frames are basically lower bandwidth. So it can dynamically adjust it based off the activity. Less activity can make that GOP size longer. As activity increases, it makes it shorter. And then the last one is the frame rate can be dynamically adjusted based on whether there's motion in the scene or not. So if there's no motion going on, it can drop the frame rate down, and then as soon as motion happens, it brings it back up as well, and it's all handled on the camera side. So not all cameras do all of this. In fact, only one of them does all of this that I'm aware of, at least. But they kind of vary in that regard. So who offers it? Currently, the following list here, they have some sort of smart codec available. There's likely others that I am not aware of, but I'll let you look at the list there and kind of have the names of what they are. But off to the side too, the little screenshot there I want to point to as well. So this is a quick test I did, and you'll see these cameras here when we get to the demo. But I went in and did a recording for 5 minutes on this camera. It's the same exact camera looking at the same scene. I just have it replicated and have different compression settings set on it as far as for the smart codec. It's an Axis camera, and you can see in the 5-minute export the different file sizes that resulted from that 5 minutes. So when Zipstream was completely turned off, we were about 44 megabytes. And if you go to the opposite end of the spectrum there, when it was set to extreme, which applies a lot of compression to the areas where there's no activity and such, we were down around 31 megabytes. for 5 minutes. If you extrapolate that out, just to give an idea, say one of those cameras was recording for 30 days at 30% motion, that no zip stream in that 30 days would be about 109 gigs of video. The extreme compression one would be about 78 gigs of video. So it's about a 30 gig difference there for a single camera across 30 days. So you start adding that up to hundreds of cameras and stuff like that, and you can see how the storage savings plays in. And then also you'll see here when we get to the demo, kind of the bandwidth savings as well. So what are pros and cons? The pros are pretty standard. It's just a bandwidth and storage savings of 50% or more. Sometimes less. It all depends on the activity in the scene, but it's just a bandwidth savings over standard H.264 and H.265. The cons for those who are a little more familiar with our software. So if you're using a dynamic GOP adjustment, by default in our software, we do motion detection on just the keyframe. So typically we're detecting motion once a second. If you're doing a dynamic GOP, then it's best to not detect motion just on the keyframe, because if your GOP is dynamically adjusting out to 5 seconds or 7 seconds, that means you're detecting motion only once every 5 or 7 seconds, which isn't very good for motion detection. If using dynamic GOP, some momentary drop in the network or glitch could also lead to a larger chunk of video being lost, depending on other factors as well. Just because you need that keyframe to create the GOP. So if the network drops when that keyframe happens, then basically the whole rest of the GOP is lost because all the other frames don't have anything to reference back to. And the last one is there's really no way from a storage and bandwidth calculation aspect to calculate the benefits of smart codecs, because there's so many variables involved. It all depends on how much activity is going on in the scene, depends on what settings are available to do this. Like some cameras or some manufacturers, it's a simple on-off switch on the camera basically, and there's no settings at all. And then you have someone like Axis who has all those options like off, low, medium, high, higher, extreme. Then they also have, Axis can also do the dynamic GOP, and you can set how long, the maximum length you want that GOP to be. And Axis also does the dynamic frame rate adjustment, where you can go in and even set a low end frame rate. So there's so many variables involved that it's just not possible to calculate the benefits really. Oops. So quick e-learning thing. If you are interested in learning more around this, there is an e-learning module in the fundamentals of IP called Codec Fundamentals, and it talks about codecs in general, and also talks about smart codecs as well. So it's kind of a way to jump in and learn a little bit more. And now we will jump into an actual demo here. But before we do, let's see what questions there are here real quick. Let's see. Dave Newegg asked if we're compatible with all of those. All the ones I listed, we are compatible with. And there may be more as well, but yeah, all the ones I listed we're compatible with. Typically, from what I learned from talking to the driver team, is typically we don't even have to do anything in our software to be compatible with it. I think there are some exceptions, but generally speaking, it more or less just works. And Alex, I've heard the same thing too. You mentioned he says that he was told that the smart client may show no video in a camera window if you're using an Axis camera with both dynamic FPS and GOP together, because the recording server isn't receiving any frames, so it thinks it's down. I have not witnessed that. I have heard that before, but I'm going to connect here real quick. Looks like my network connection decided to go down. Let me try this again here. So here I have an Axis camera set up with what Axis calls area view, which allows you to basically have multiple virtual cameras coming out of the camera that you can apply different settings to. So I set up 8 of them and have different settings displayed on them. So you can see the first one here, the top left, is with zip stream off, and then as you go left to right, we get the low compression, medium compression, high compression, higher compression. These are Axis's terminology. It's kind of silly. And then extreme compression. And then these bottom two, this bottom left one is low compression with dynamic frame rate. So, and its dynamic frame rate is set down to go to low end of 1. So you can actually see right now, it shows here that it's streaming 1 frame a second. And then this next one over is medium compression with dynamic frame rate, with the bottom end set to 3 frames per second, and a dynamic GOP set out at 60 frames per second. All these cameras are set for 8 frames per second. So you can see right now these bottom two, they're showing 1 frame a second, and this one's showing 3. So they're sitting at the low end right now. A car just drove by, so you can see it jumped up to 8, and then it just dropped back down again. But if you look at the bit rates here, you can kind of get a visual of the differences here. And sometimes you'll see one that maybe is set for lower compression. It might jump up higher than another one momentarily, but generally speaking, you can kind of get a visual of how these look and the differences in how the different compressions work, especially if you look down this one in the bottom in the middle. Right now it's showing a bit rate of 3 kilobits per second because of this dynamic GOP. And then it's jumping up here a little bit up to 100 or something like that, but it's an incredibly low standing bit rate. And then I was doing some digging around in video before I did this, looking at video last night, and I'll show you kind of what this looks like. So I'm gonna go ahead and play this. So it was a little windy here last night. So as we're playing this here, if you watch, so we've got low light, which automatically increases bandwidth. And then we got some wind going on that'll kick in here, and you see that large tree moving around here. I want to actually go closer to the bookmark here where the wind starts. So you can see like this top left one with no zip stream at all, so no smart codec. We're sitting at roughly 2.5 megabits per second compared to the one set for extreme compression, which is going as low as 1.5 megabits per second right now, around 1.7 or so, because it's still able to sit there and kind of put a higher compression on the areas where nothing's going on, like all this dark area over here and such is getting a higher compression on it. You can also tell, if I jump back into here, see if we can get a good shot of it, maybe in these trees. If we look at, and it may be hard to tell over the Skype meeting, but if you look at the leaves on the red tree here in the background, between the two, if you look at them closely, you can tell the compression difference. You can tell that this is only a 720p camera, so it's not super crisp in either one. But again, I don't know how it's coming over Skype, but it's sitting in front of it. It's very easy to tell that the one with no compression, there's a lot more detail to the leaves, whereas the one on the opposite end set for extreme, it almost just looks like a mush of red in there. And that's where that kind of dynamic compression comes into play. So areas where stuff's moving and such, the quality would look the same between them, but anything that's not showing activity, it will put that higher compression on there. That's all I have for that. Let me see if there's any more questions here real quick. Steven asked, will dynamic FPS still send keyframes? So we should get 1 frame per second minimum. Yeah, that's if you don't have dynamic GOP set and you're just doing just dynamic frame rate, then yeah, it's essentially just sending one keyframe per second if you don't have dynamic GOP, because our default GOP settings are 1 frame per second. And there may be some variances on that, but generally speaking, I'd say that's true. Any other? There's another question. All right. Will the dynamic GOP and FPS create more client load for decoding when compared to having them unchanged? That's a good question, and I have not tested that to see. But that would be a very interesting thing to check and see whether it would put more of a load or less of a load, or be more or less negligible. I don't know if anyone else, pre-sales wise, or anyone has ever played around with that and has any thoughts on that. If you do, feel free to chime in. It looks like there's another question coming through here. I would agree with that, Dave. That would be my assumption. Dave was thinking it would seem like less, since it's being simplified. There's lower compression on the video and stuff like that, or more compression but less quality. And Steven's torn. I'll do some testing here when we finish up and figure that out. It wouldn't take too much to test. Harry's asking, don't dynamic codecs only matter between the camera and the recorder? Does the client pull video from the camera? The client's not pulling from the camera, it's pulling from the recorder, but our recorder is essentially just sending out what the camera is sending in. So it benefits both sides. You get the storage benefit and bandwidth benefit and such to the recorder, but then you get it from the recorder out to the client as well. Stephen asks, can we use SVQR with Zipstream or other smart codecs? I wouldn't see why not. I can't think of a reason why you wouldn't be able to, but I've never tried. And we have two more questions coming in. That's still an unknown, Harry. Harry's asking, will some of this change when we release VPS, the video processing server, whenever we decide to release that? There's no guarantee the VPS will handle streams to the client. That was kind of a proof of concept they showed on Workplace a while ago, but there wasn't a guarantee that that's the route that things would go. Do we have a recommended compression, or is it just based on customer needs? That's a good question, Colton. So with Axis cameras in particular, they all now default to the low compression setting for Zipstream. So that's kind of the default out of the box setting. So you automatically have some smart codec functionality turned on. With most other cameras that I've seen, the smart codec functionality seems to default to off. That may have changed in the last 6 months to a year though, but other ones I've seen, like from Hanwha and trying to remember some of the other ones I've seen recently. I'm blanking on them, but most of them, or any of them that I've seen that I can think of off the top of my head, have defaulted to off outside of Axis. But most of them too, as I was mentioning earlier, most of them, the setting is literally just an on-off. There's not a whole lot of them that have any kind of tweaking involved. And if they do, it's very limited compared to what Axis do. But most of them I've seen is just a simple on-off, which is it's turning on the compression stuff. And then I think with some of them, when you turn it on, it automatically enables a dynamic GOP setting as well. So it kind of seems to vary from manufacturer to manufacturer. With dynamic GOP, how is grooming working? That's a good question, Uwe. And that's another thing to point out. If you're grooming and I'd say if you're grooming, you wouldn't want to do dynamic GOP, because taking an example where you have 10 frames per second set on the camera and you set a dynamic GOP with a threshold of say 100, just as an example. So in some scenarios, you could be having a GOP that's 10 seconds long, which means you only have one keyframe in there. So if you're grooming that chunk of video, then you're getting one frame every 10 seconds. If you're fine with that, then obviously go for it, but you would have no control over that aspect. So you would have sometimes where that you might be getting a frame a second if there's enough activity and that GOP had shrunk down to 10 frames. And then you could have other times where you would be getting a frame every 10 seconds if there was less activity and it stretched out. Alex asked, if you enable dynamic GOP, I assume disabling keyframes only VMD isn't automatic, which means no one probably does it. I'd say that's your first part is correct, Alex. It does not disable it by default. And your second part is probably 100% accurate. that that people don't make the correlation there between the two. Yeah, I'd say it's 100% accurate. And the flip side of disabling the keyframes only motion detection is then it puts a higher load on the recording server from a processing standpoint as well. So there's like anything else, there's a give and take in all of this. But typically if you needed to, especially if you had a low bandwidth scenario, doing the dynamic GOP would help greatly on the low bandwidth scenario, and the trade-off of having a little higher processing on the recording server would likely be worth it, especially if it's something that you absolutely had to have. So if you, Alex is asking if you're doing dynamic GOP and you don't disable the keyframes only, is it just poor performance? And yeah, I mean, you would miss stuff. If you take the example earlier where you have a camera set for 10 frames per second and you set a dynamic GOP with a high-end threshold of say 100, so worst case scenario, your GOP could be 10 seconds long. That would mean that you're detecting motion once every 10 seconds. So you'd have 10 seconds to miss some sort of activity going on. And you'd probably end up with a call into support at some point trying to figure out why you're missing video, and that would be probably a really fun one to troubleshoot because it's not a place that you would look at right away. Alex said, any recommendation for server calculator if someone's using smart codecs? Should you just drop the image complexity level, maybe from medium low to low? Yeah, it's like you said, it's very tricky. But yeah, if you know they're using smart codec, it's kind of one of those things, like especially if they're using a smart codec in an outdoor scene where usually the image complexity is a little higher, you might in the calculator bump up to medium if you know they're using smart codec, especially even if it's just on the compression side, going with medium low setting, or if you normally use medium low, going with low. It's kind of a give and take because our calculator needs obviously some updating in some of that aspect. But yeah, I mean, I would, if nothing else, if they're exterior cameras and you'd be inclined to go to medium, I'd say in most cases you're probably safe to keep it at medium low. On interior, dropping down to low, it might be risky. It's hard to say. Steven says he drops the complexity, which is the likely setting to do. We could add some more complexity options in the calculator or something like that to kind of account for some of that. But yeah, I mean, that'd be the likely one to do. The nice thing though is most, with the calculators, most people overestimate the motion percentage anyway. So there's always a buffer on the storage. So if you underestimated the bit rate, it's likely not going to cause an issue in the long run. All right. Any other questions? Okay. We will wrap it up. Thanks everyone for joining. Everyone have a great weekend, and we will see you all later.